We're going to do the basics of a scatter plot. This is going to be the first of a couple lessons on linear regression. The things that you'll need for today for the basics of the scatter plot is you need a piece of graph paper, you need a ruler, a straight edge, and a copy of this experiment that I'm going to project in a second. So get those, and then what you'll need to do is read this experiment, read the data table, and then copy the data table down onto your graph paper. And once you've copied the data table onto the graph paper, you'll be ready to begin. So go ahead and pause the video here, and in a second, we'll look at what's being studied. All right, when you're doing a scatter plot, you've probably already done one variable statistics. Those are things like histograms, bar graphs, pie graphs, dot plots. This is two variable statistics, and what you have is you'll have two variables, and they both of the variables have numbers. They're called numerical variables, not categorical. You won't be able to use a scatter plot with categorical variables. So we have two variables, two things that are being studied here, and two different values for each of these variables. The first thing to do when you do a scatter plot is to identify what your explanatory variable is and what your response variable is. Now, these are two new words to you, so if you can think about this, and there's a real easy way to remember this. Your explanatory variable is your independent variable. You might have heard that vocabulary from science, independent and dependent variable. Now in statistics you can't use independent and dependent variables because independent and dependent have something to do with probability. So we're not going to be able to use those words. So instead we use explanatory and response. One way to remember this is the independent, that begins with an I, that's a vowel, is going to be the same as the explanatory, that begins with an E, that's also a vowel. And then the dependent is the response variable. Dependent begins with a D, that's a consonant. R is also a consonant. So there's one way. The other way I like to remember this is if you don't know what your explanatory variable is, what's the first two letters? X. So that should tell you that this is the x-axis. Okay, and then if the other one's not the x-axis, that's going to be the y-axis. All right, so let's look at the study and find out what's the explanatory and what's the response variable. The study is talking about hours spent resistance training, weight training. And when someone does a certain amount of hours, after 2 weeks, they look at their max and then they get one of these. So you can see that this is input, this is output. The input we learned in science is going to be the independent variable, and the same as the independent variable is the same as the explanatory variable. So here are your explanatory variables. These are the response variables. So on your x-axis, on your explanatory variable is going to be the hours spent training. Your response variable is going to be the max leg press. The second thing to do now is to label your increments on your graph. So go ahead and draw your graph. I would recommend that you use 10 blocks each way at least. When you look at your data table, the smallest value for hours spent training is 1 and the largest value is 9. So we're going to order these from 1 to 9. If you look at your response variables, the smallest value is 200 and the largest value is 375. So we're going to go in increments probably of 25. So 200, 225, 250, and so on. Okay, then you just match your ordered pairs and start graphing. So I'm not going to graph the whole thing on this video, but what I recommend that you do is I will graph a couple together, and then you can pause the video and pick it up where we left off when it's completed. So let's look at 200. So I'm going to just put an X there actually. It's better than a dot because it shows you almost specifically kind of you need a bigger point for these scatter plots. You could put a plus sign. A lot of calculators have a plus sign. Then I'm going to do number 2 hours spent training, and that's 200. Okay, and then look for another 2. If there's no other 2s, then 3 was 250. And then so on and so forth, or you can just go down the list and graph those, and then pause. I'll pause this, and then we can pick up and look at what the scatter plot looks like. Okay, if you've completed all of your ordered pairs on your scatter plot, you should get something that looks like this. Now there's a couple things that you need to look at. One of the things was that 2 of these have the same hour spent training, and they also have different values. So I'd just like to call your attention to the fact that there were 10 different women on this college basketball team who participated in this study. So 2 people spent 4 hours training. That's something that you're going to see in experiments, that some people have the same, or some results that you observe are going to have the same explanatory variable. There's nothing wrong with that. It's not extraneous. You don't throw that out. We're talking about 10 different women, and 2 of them happen to be training for 4 hours. And then also those 2 happen to have very different max leg press weights as well. So there's nothing wrong with having 2 of the same results. This is just what you got in the experiment and what you can graph. Okay, the next thing that you should see from the scatter plot is, the reason why we call it a scatter plot is because all of the x's are scattered and there's no real pattern for them. What we do with the scatter plot is we look first to see how close all of these points are, and for some scatter plots you have them scattered all over the place and seemingly no pattern, and for other scatter plots you have them all lined up. Some of them could be lined up this way as well. Some of them could make a circle. There's just a random pattern just depending on what your study is. Okay, the amount that the x's or the dots are spread out, what you're going to do later is you're going to find out that this has to do with something called the correlation. And the symbol for correlation is R. The other thing that you can do with a scatter plot is you can draw a line. And when you draw a line, you want to draw the line of best fit. And that's pretty self-explanatory. You're going to draw a line through most of these data points that kind of generalizes the trend. If you can kind of see this, it looks like most of these are going like a slanty line up. Now I'm not going to connect all the dots, and that would be actually impossible for some of these that have 2 results. But what I'm going to do is I'm going to draw a line that I think best represents how this data is going. So it doesn't have to hit any of the points. It doesn't have to hit all the points. It could hit one of them. Just whatever you think is the best line that shows the trend of what this data is representing. Okay, so this is the line of best fit on our scatter plot. So let's review what you learned today. As you just learned the basics of the scatter plot. You learn how to read an experiment, figure out what the explanatory variable is, what the response variable is. Then you graphed it, and when you graphed it, you found out that when you put all your points on there, they're scattered. But there is a general trend to these. These seem to be going to be increasing as you go from left to right. And A lot of these x's don't fall along the line, so you're going to find out later something about the correlation between these two. There's a number that corresponds to the correlation, and the variable that you use or the way that you represent correlation is by r. So what we did is we drew the line that best fit these data points, and when you draw the line, you don't have to connect the dots. You shouldn't connect the dots. You should just draw the line that best represents what you see as the trend. Okay, that's it. Next, what we're going to talk about in the next lesson is about the least squares regression line, or the LSRL.